Okay, so here's the solutions guide for the 2.1 and 2.2 study guide. First of all, let's do a simple limits problem, okay? Now, not all these are very complicated. Anytime you can, just try to plug it in. See how it's the limit as x approaches 2. Always try to just plug in. See if you can legally put that into the x and evaluate that thing. Sometimes the limit is the same thing as a function value. So we have 15 minus 8. 15 minus 8 would come out 7, and that's still under square root. You get square root of 7. So that is the answer. Not any big calculus or major thought into that. Let's go to the next one. So we have, let's take the limit as x approaches 3. Again, this is a polynomial. Polynomials are continuous functions. They're very well behaved. So you can just plug the 3 into this function right here. So we're just going to do 3 squared plus 5 times 3 plus 4. All right, and then so we get it's 9 plus 15 plus 4. So 9 plus 15 plus 4, which comes out to, see, 24. So 28 is what this comes out to. So nothing special about these first two. Now let's look at where you actually need to maybe use a little bit of thought and calculus. So let's focus on this one right here. We want to take the limit, and here's how you read this as x approaches 0 from the left. So I'm going to try to approach 0, but from the left. Here's what that looks like. I'm getting closer to 0. I'm getting closer to 0. I'm on the left side of 0 still, approaching it from the left. Now, here's the thing. I know that at 0, the function value is 2 if you look at where the little bubble is. But the limit as I approach 0 from the left, it appears to be 0. Okay? So it appears to be 0. As you approach it from the right, you'll notice you get the same idea. I'm going to try to approach this thing from the right. As I approach it from the right, now I'm taking x values that are really close to 0. So, pretend like it's 0 0.1, 0 0.00001. Take numbers that are really close to 0. And here's the thing. Same thing. Since both the left and the right agree, since the left is equal to the right, you're going to get the same answer that the limit is 0. Now, the function value at 0, that is this thing right here. The function value is not always the same thing as the limit. So the function value is 2. It's because we have a discontinuity there, and this is a removable discontinuity in this case. Not that you have to be familiar with those terms for this particular quiz. That'll come later. But it is interesting to know that when your limit and your function value are different things, that's a discontinuity. And another thing to focus on is when your left and your right limit agree with each other, see A and B, only because they agree with each other does your limit as x approaches 0 exist. If the left and the right disagreed, you'd have something else. Let's look at part E. Limit as x approaches 3 from the left. So I'm going to approach 3, but from the left. I'm going to get kind of close to 3. I'm going to get closer and closer and closer to 3. Now, I get really close to this. All right, so the limit as x approaches 3 from the left is going to be 9. But look what happens when I try to approach 3 from the right side. I try to approach 3 from the right side, I don't get 9. As I approach 3 from the right, and here's the thing, I know I went all the way up to 3, but even if I stop at 3.1, I'm still flatlining the whole time. It's 0. So the left guy says 9. The guy from the right says 0. They can't agree with each other. So the limit as x approaches 3 in general does not exist. I'm just going to write D and E. All right, next ones. A little tip to be familiar with is that uh, anytime you have sine of x over x, we can actually show this graphically. If you pull out your calculator, if you don't remember that the limit as x approaches 0 of sine of x over x is 0, let's go, of sine of x over x is 1. Let's just go to our calculator and we're going to show that that much is true. I'm going to type sine of x, okay, and then over x. All right, so I've got the function in there, and I'm going to just go to my standard window, zoom 6. If you notice, when this thing graphs, you see how it goes right there at 1. If you want to zoom in a little further, another good zoom for these is zoom trig, because this is a trig function, of course. There you go. See how right at 0, it really obviously tends to go right here. Now, let me change these numbers up a little bit. So we've at least confirmed this part. But let's confirm this second part, that the sine of ax over bx is equal to a over b. What that means is let's just change these coefficients. In front of this x, I'm going to insert, let's just insert a 6, okay? whoops, I did not mean to type that. Let's do second insert, and let's put a 6 right there. And I accidentally deleted my X, so I'm going to put that back. So let's put a 6 right there. Watch what happens to your graph. It's going to go up to, and like you have to zoom out in your window, but I guarantee you that goes up to 6 because that's 6 over 1 coefficient of, and so you just take the quotient of the coefficients. That's how you get this. Let's make it a little more interesting. Let's change the denominator to 2x. Well, what's 6 divided by 2? 6 divided by 2 is 3. So if you graph that, I guarantee you, as x approaches 0, which means basically at your y-axis, you're going to get, you see it goes up to 3 perfectly here. Now, the value isn't actually 3 because there is no value. There's actually a tiny pinhole there. I'll show you. I'm going to try to find the value of this function. I'm going to plug in 0, and your calculator, it says, wait, there is no value. It's just leaving a blank here. But let me show you something else. Second calc, let me do something really close to you. I'm going to do 0.000000001. Now, it says 3, but really, it's actually like 2.999999999, and your calculator just rounds up to 3. So it's, and if you notice that this here, it does scientific notation for that 0.0009. So this is a lie. It's not actually 3, but your calculator rounds up. But the idea is this: we care about the limit. So as it gets close to 0, so here this one's going to be quotient of coefficients. That's just going to be 1/2 right here. So 1/2. This one right here, well, see, this is, if you take the quotient of the coefficients, remember quotient means division, those coefficients, and then you have 1/2 right here, but then times 8, so 8 times 1/2 is going to be 4. Here, the limit as x approaches 0, again, is going to be, here it's 1/2, and now I'm going to plug 0 into these other things. So 5 times 0, 5 times 0 is just 5, and then plus 4. So the thing is, this just goes to 0 when you plug in 0, because you can plug it into this little linear function part. And then you have 1/2 minus 4. Be careful, the negative does apply to the 4, which gives you negative 3.5. That's the limit there. All right, let's do some other quick ones about finding the limit if it exists. Let's look at the limit as x approaches 4 from the right of 6 over x minus 4. Now, if you know about your parent functions, if you notice that this actually has a form that's very similar to 1 over x, so 1 over x just looks like this. The only difference between this and 1 over x is that this thing is shifted to the left by 4. So 1, 2, 3, 4. If you have trouble convincing yourself, you can graph this on your TI-84 calculator. But I can guarantee you graph this, it will look something like this. And I'm feeling some of you don't believe me, so I'm going to go ahead and here I'm going to hide this function in case I want to come back to it later. But I'm going to graph this guy right here. I'm going to graph 6 divided by, open parentheses, x minus 4. And I'm going to graph in the standard winner, hit zoom, hit 6, which is zoom standard. And, oh, wait, I was wrong. Actually, it's shifted over to the right. I made a mistake there. So, yeah, whenever it's the minus 4, it's shifted to the right. So, rookie mistake there. This thing, if it was x plus 4, it's shifted to the left. Remember, vertical shifts are, they make sense, but the horizontal shifts are sort of counterintuitive. But it just means like the minus 4 is kind of like it gives you a 4-second head start, sort of. But it looks like this is what it looks like. And here we have a vertical asymptote. Remember, you get a vertical asymptote anytime you divide by 0. All right, so we have the limit as x approaches 4 from the left. If you follow this thing as x approaches 4 from the left, right when it starts to get toward 4, it just plummets down, which, by the way, x approaches 4 from the left, that is actually this part right here. So this one is going to be negative infinity. All right, as you approach 4 from the right, though, so this one's x approaches 4 from the left. Let's approach 4 from the right. All right, I'm trying to get close to 4, so here I'm at like 5. Here I'm at like 4.5. Here I'm at like 4.00001, but it's going to blow up. It's going to go to infinity like so, right? Now, if I try to approach 4 in general, well, one guy says infinity, and one guy says negative infinity, so they can't agree, so the limit does not